Share the given question is two point charges A and B having the charge plus Q and minus Q respectively are placed at a certain distance apart and force acting between them is F. If 25% of charge A is transferred to B, then the force between the charges become what would be the answer that is the thing we are going to discuss now.
It is given in question two point charges A, this is point charge A as well as the point charge B having the charges, one is having plus Q, another one is having minus Q. It is located apart or distance. The distance separation between the two charges is R. Okay, the force acting between them is in general this would be given F. This is the first part it is given. The next part, if the 25 charges of A is transferred to the B, that means the charge plus Q, it is A, it is present. You can separate these charges into 0.75 Q plus 0.25 Q. That means the 25%, this is the second one is represent the 25% charge. It is if it is transferred to the B. So you can just convert this into fraction 0.75. You can write it as 3 by 4 q. It is 1 by 4 q. This is the net charge plus q on A. Now we are going to, it is going to transfer to the B. So now the charge on the A, that would be, it will be 3 by 4 q. This charge will be there. Now we are transferring this charge to the B. So the B, already it is having minus q. If you are transferring 25%, then it will be 1 by 4 q. This will be the net charge of B now. So the charge on A, the charge on A now, after transferring 20%, the charge on A is equal to 3 by 4 q. Now the charge on B, that would be after transferring, it will be minus q plus 1 by 4 q. It will give uh, minus, it is 3, if you cross multiply it is minus 3 by 4 q. Now what is the now the new charge, the force between the two charges? We know from the Newton law, the sorry, from the Coulomb law, the force between any two charges, the force between any two charges, suppose if you are taking the initial, this is the first condition, this is the initial condition, this diagram before transferring the charge, this initial diagram. Now if you are taking this diagram, the force between these two charges, you can generally, using the Coulomb law, you can tell the magnitude of the force, that will be equal to 1 by 4 pi epsilon the charge on A, the charge on B, divided by the distance between them square. So this charge would be equal to 1 by 4 pi epsilon naught minus q square by r square. This minus sign represents there will be the attractive force between the two charges, because their negative force means one is positive charge, another one is negative charge. So the positive negative charge will attract each other from the according to the properties of the charges, the from the Coulomb law. So it's attractive force. So whenever you are having negative sign, it's attractive force. Now this is a general expression for the force between any two charges from the Coulomb law, from Coulomb law. Now what we are going to do for the new configuration, we are going to calculate the force between the two charges. This is our new diagram after transferring the 25% of charge to the B. So after transferring 25% charges to B, then the new force, in general you can call it is an F prime 1 by 4 pi epsilon. The charge on A in the new configuration, it is 3 by 4q, because it's a general expression. It's the force between any two charges. In general, it represented by the product. It is directly proportional to the product of the two charges and inversely proportional to the distance, square of the distance between them. So the first charge is 3 by 4q. The second charge, here it is, here it is minus 3 by 4q divided by the distance. We are not changing the distance, it is remaining the same. This configuration also, or after transferring the charge, remain the distance between the are same, so it is r square. So the F prime is equal to 1 by 4 pi epsilon naught. If you are multiplying these two, it will give minus 9 over 16 q square by r square. If we are taking the 9 over 16 outside, then inside is minus 1 by 4 pi epsilon. It's a q square by r square. This is nothing but the original configuration force. This system is having that force. So the F prime, the new force after transferring the charge, that would be equal to 9 by 16 times the old configuration. So this would be the best option after transferring the charge 25% to the B.
So the right option, it would be equal to 9 by 16 time F. The second one is the right answer.